Okay, so hello everyone. Today we will see now a non-recursive in-order traversal. So how do we perform here non-recursive in-order traversal? We have to see. So for this, as you can see, the word here is non-recursive. So definitely we require to have here a stack. So how we can perform here a non-recursive traversal by using stack, we will see. So for this, the steps are very simple. We just need to have a stack here first. So this is the stack I have used. So into this stack, what we perform, we first start traversing. So if I will say this is what my temp, which is initially holding your root. So we just keep traversing all the nodes from the root towards its left side. So first, what do I have? I have here a root. So I will just add that root into this stack. So I will add 7 here into this stack. And after that, I will just keep moving towards its left. So first step you can consider as push your node into stack and then move towards its left. So 7 has the left element as 8. So again, I will move towards its left and I will push that into stack. Again, for 8, we have a new left child. So I will again push that new child into the stack, that is 9 here. So as of now, we have added here the all three new nodes that are here respectively 7, 8 and 9. So as we have now added 9, so you can see for 9, we can't move toward left because 9 don't have any left child. So what we can do here, we have now performed here push operation, as you can see. Okay, so after push, now we can go for pop operation. So pop means we will keep removing your nodes. So as we will remove the nodes from the stack, so at the same time, we will print it. So as I will remove here 9, so I will print it. So 9 will be the output. Next, after popping this 9, do check, do we have any right of this 9? So we don't have any right child for this 9. First, what we have done, we have just pushed all the node into stack, then we have moved towards its left. So for 9, we don't have any left. That's why after popping, we are checking for right node. But right is also not available. So we are now going to pop the next node, that is 8. So as I am popping the 8, I will print it. And after that, I will check for its right child. So for 8, we have right child. So how I will now get the new stack? So new stack will have the previous element 7, which is inserted here. And as I'm getting here the 6, so again I will push that 6 into the stack. This 6 has to be pushed into the stack. So what I will do, I will just push 6 into the stack. Okay, again for this 6, check for the right element. So right child, we don't have anything for 6, so I will again go for popping from the stack. So as I will pop the 6, again I will print it. So 6 is here, I will print it here. Okay, after popping, again do check for the 6. Do we have any right? We don't have anything as the right. Okay, so what we can do now, I can again go for popping. So popping means what? I will pop here the 7. So again, for your understanding, what I will do, I will just write here the steps. So how I am going to perform the steps, just let me go here. Okay, we have here word pads, so we will just write. So the very first step is here. So the first step is we are pushing the node into stack. That was your step 1. Step 2 is move towards its left. Its left. This steps we have followed for how many nodes? We have followed for this nodes from 7 to 9. Okay, but when we don't get any node, we are just going to pop the nodes from the stack. So that will be your next step. So this processes we have followed. After certain instance, we move for the next step. That was like until your stack is not empty, not empty. What we can do, we can just pop the node from stack. That was your step number 3. So until the stack is not empty, we are popping that node from the stack, and apart from this, we are moving towards its right. Move toward its. So these are some steps that we have to follow. So if we are getting, let's say, some right child, so how we are going to follow the steps? So into this example also you can see, if I am getting any right child, let's say for 8 also we got a right child, that is 6. So we are moving again towards its left. Means we are going to follow the same previous step. We are again pushing that 6 into stack. Then if we don't have any right child, so we are popping that 6 Okay, and then we are printing it. So this steps we are following. So after popping, we are moving towards its right, and okay, one step is skipped here. That was step number 4. After popping, we generally print the node. Print the popped node. Okay, the node you are going to pop has to be printed, and then we are moving towards its right. That was a step number 5. If you are getting any right child, then we are repeating the step number 1 and 2. So that is repeat step 1, and then you can say 2. So these are nothing but this is your actual algorithm of non-recursive in-order traversal. Okay, so everyone has to follow this one. This is the only algorithm for non-recursive in-order traversal. So till now we are at this 6. So after this 6, if I will now pop 7, so what we can get? Now 7 is removed from the stack. So I will get here again this next step. So next step is telling you after popping, just print it. So you will print here 7. Okay. So 7 is printed. So after this, what we can do, we can move towards the right child of 7. So right child of 7 is 5. So again, I will push that node into stack. So this node is here 5. Okay. So as I'm getting 5, so again I should move towards its left. Okay, so the 5 has again 4 as left child, so I will move towards its left. After that, again do check for that 4. Do we have any left child? So we don't have any left child for this. So what I will do, I will pop the 4 from this stack. So if I will pop, I will print it. This is it. Then for this 4, if you are printing it, so do check. Can we have right? We don't have anything, so don't worry about this. Then the only element left in the stack is 5. So again, pop the 5 and print it. So this is the step, like I'm popping that 5 and I'm printing it. So here, after popping the 5, now I am getting the stack with no elements, no nodes. So this is, we can say as empty stack. This is empty stack we have. Okay. So here now how we can change or how we can implement now this in order non-recursive traversal or non-recursive in order traversal. So for this again we will require the same 4 things. Again I am telling you the steps are very simple and these are same applicable here. These are the steps. Like very first is we are going to push the node into stack. We are moving towards its left. Then until the stack is not empty, we are moving. We are just printing that node. After that, we are moving towards its right and we are again repeating the same previous steps. So for your understanding, what we can do, we can again just copy this. We can try to paste here. Okay, so it worked, I think, here. So let me just reduce the size. Okay, so just for our understanding, we can do this. So this is what this is just we can consider. Okay, let it go. We will go with actual implementation now. So for actual implementation again, we require first a node class like we have defined earlier. So I will just draw that node class here. So first header file we have added. Now I will write here using namespace standard to take some standard input and output. Now you can define some node class. So into this node class, we can have the members of your node. That will be what? Some data you can provide, and next is 2 pointers for your left and right child. So I will just declare those all the public elements. So here we have enter data. Next we have node star left and star right. These are 2 pointers which will point to the left and right child. Okay. So if you are not understanding like what thing I am doing, so you can simply go and watch my previous videos where I have explained how to create a node and how we can just go for let's say implementation of general binary. So this is just a simple node creation. Then we used to create here one constructor. That constructor will be called automatically whenever you will create an object. So data equals to x you will pass. Next thing here, we used to create some create function. It will be used to take the input from the user. This is a kind of pointer function. So here again I can declare some x. Here the user will ask or we will get the prompt for the user to enter some data. We will store that data into X again. Okay, here we will check if that X is, let's say, some value which you are not allowed to create a new node. I am telling that value is what, -1. So in that case, no new node should create. So it will return what? It will return here. Okay, so the statement is telling you if the user will provide -1 as the input, so no new node should create. But what if the user will provide any new value? So you should create a new node, and the new node is what? That is the object for X. Okay, that object will store your data X. So I'm just telling that node is what? Root. Okay, so you can just define here root first. So node star root. Okay, this is a kind of pointer we have defined. Now apart from this, now the object is created for your single node, that is root here. Now you can ask the user to enter left and right child. So you can simply ask enter left of, here we can say X. Again I am telling you, I have explained all these things into previous videos. So if you could not watch that, please go and watch this so that you will understand this, like how I am writing this. So here left of that X we can store into what? We can store into, I think, roots left. And for that again we will call the same function, that is create. And for right child also I will repeat the same process. I will just write here enter the right of X. I will just store that into a right pointer. So roots right. And ultimately this function will return what? It will return root. So I will just say return root. Okay, so this is what, this is just a create function. Apart from this, now we require a stack. So I will just create a stack class. So into this stack class, the very first thing I am defining is the top. So top is what? Again, if you could not understand like how I am defining stack, so you can go again watch the previous video, because I have already created the previous videos for all these things. So if you are still new, so I will just tell you in short, like if I am telling this is the stack we have, just let me go here. Okay. So if this is your stack, so in this stack, what we have, this is what, this is your top, which is allowing your insertion and deletion of data. After that, apart from this top, we know that the insertion operation we are calling by the name push. Okay, you can write any name, but standard naming is push and pop. Next operation, like for deletion of element, we call the operation as pop. So we require two methods, like push method we require, pop method we require. So we'll create the functions for this. Apart from this, the elements we are storing into stacks are stored one after another. We call this data structure as last in, first out, LIFO. Last in first out. So the element which we are adding last will come out first. So if I want to add any element into stack, if I want to add 5, so it will be added at the bottom. If I want to add again 4, so it will be added after that. If I want to add 8, so it will be add above 4. So like this the elements will be added here. So this is the working of stack. If I want to now perform a pop operation, means a deletion operation, so all the time the 3 will come out first, and where it will be done, it will be done at the top only. So remember, all the time all these elements are indexed, like the 5 will have the index 0, 4 will have index 1, 8 will have index 2, 9 will have index 3, and 3 will have index 4, like this. So though I am storing the single element, it will be follow index 0. So remember this. Okay, now we can go for implementation of stack. So I have already explained in different video, but here also you can understand this. So now I need to define the size of stack. So for node class I am creating some we can say array which will store your nodes. Okay, so I am just assigning the size is what, just a 10 as of now, because we don't have more than 10 nodes into our tree. Okay, you can provide any size. Then initialization of that stack in the constructor is what? Initially the stack should be what? It should be empty. So stack empty means top will be what? Top will be less than 0, means it will be -1. So -1 means it's an empty stack. Remember this. Okay, so this is just telling you, like we have defined the empty stack. Apart from this, we can say we have one push method. So I will say this is push. So push method is taking what? It's taking your node as the argument. So I will pass your node. So node is root, let's say. Okay, I'm passing here the root as your node. And if I am passing root into the push function, so definitely root will be stored into this function. And where it will be stored? So it will be stored into your st array. And if you are storing your node into st array, so definitely the size of top will be what? It will be incremented. So initially it's empty, that is -1. So now it will increment first. So top will be first pre-incremented, then it will store the value of root. Means initially the top will be 0 from -1, and then it will store the root, whatever the user will pass. Okay, so that is the meaning of that statement into pop, sorry, into that push. Now we can go for pop function. So pop is what? Pop function will return the address of popped node. So here this function is pointer type, and it will return what? It will return the address of popped node. Hence this function is of the previous class type, node type. Okay, so it will return what? Decremented stack. Decremented stack means st of minus top we can consider. Okay, so this is a decremented top we can consider. Okay, so this is it, like we have a stack implementation. If you understood this, then we can now go for our actual thing, that is we can say pre-order. Okay, so I will now write here, sorry, we have to talk about now today in order, so we will talk about it in order. So now we will go here, and again I need to pass here the root, so I will pass that root here. So into this in order, what thing we can do? So for previous stack class, we need to pass its instance. So stack s. Okay. So what are the steps we have? So step is what we have written somewhere. We have done this. So first thing is what we are going to keep pushing the node into stack. We have written this here. We are pushing the node into stack, and we are moving towards its left. So when we will push any node into stack, whenever that node will exist. So we can write that thing here also. If the node exists, means why? That node, or your node is what? Root here. Root is not equal to what? Null. Right? It has some valid value. Then what we can do? We can just push that node into stack. So I will write an s dot push. Why I am writing s dot push? Because s is what? S is the instance of your previous stack class. Where I am going to push what? I am going to push root. Okay. First we will push that node into stack, and then we will move towards its right, left. So root will be what? Root's next value or new value will be its left. Root equals to root's left. I will write like this. Okay. So this is it. Then next is what? Next we have considered if I am just pushing the nodes. So in this case, whenever no new node is available for us for the pushing, here also you can see, in this case, when we don't have any new node for pushing, we don't have any left child for pushing, then we keep popping the node. We are just copying the nodes like this. So now, until the stack will not get empty, we will keep popping the nodes from the stack. So I will write here like while the s dot top is not equal to what? -1. Till that time, what we will do, we will just keep popping the node. So I will write here s dot pop, and where it will be stored, so you can consider any variable. I am again writing the root, so you can use any name again. Okay, so root is holding your popped node, and now we should move towards the right of that pop node. Here also in that tree we can see what we have done. If I am now popping here, let's say 7, I popped here 7. Okay, so after popping that 7, where we moved towards its right. So right of that 7 is what? That was 5. Hence we have pushed the 5 into this stack. Okay, I hope you are understanding this. So now we will do the same thing. Like we will say root is what now? Root is its right. Root's new value is what? Its right. So this is the step, but here do check again, have we really followed this? In between this, here you can see the one step is missing, that is print that popped node. So whatever the node you are going to pop, that has to be printed first. So after popping, print that node. So I will do what? I will just write here something like that root's data has to be printed. Okay, root's data has to print it. Okay, so the pop node is root. We are going to print its data. So root is what? Root is the object. Out of that object, we require the data member only, or the data variable only. We neither require left or right pointer. We just required its data. Okay, so this is the step. Apart from this, now we are at the right. After that, what was the next step? That is repeat the step 1 and 2. So step 1 and 2 is this one, this complete loop. So we can just copy this again. We can just copy this, and after that we can paste it here. Okay, so this is what? This is the same step we have repeated. Okay, so I can say now this is the complete in order function we have. Okay, so just let me run this. Okay, here also into main function we need to call those functions. So what I will do is I will again write, let's say, some mode star root equal to, I will first call create. Okay, after create, what you can call, you can call now in order function. Into in order, what we can pass root. Okay, so here go and run this. Okay, so we are getting the error like the stack is in private context. So yes, that should be public because we are trying to access the stack's push and pop function, which is defined into previous stack class. So it was declared here, and we are trying to access that into pre-order. So I need to make this public. That was private, so just make it public. You can write this as public. Okay. Now again try to run this. So here you can see the prompt is coming enter data. So now you can create the tree of any like structure you wanted to create. So what we will do, we will just create a kind of small empty tree, or we can go for any kind of tree here. So if I will just have the tree now with a 5 as your root child, it has the left child, let's say 4, right child, let's say 3. Again 4 has the left child here, we can say 6, right child 7. So we know that what should be the in order traversal. So in order traversal will be what? It will be here in order for this one. So for this in order, we know it will be what? It will be first 6 you should get, then you should get 4, then you should get 7, then 5 and 3. So we will try to create like this. So just try to draw this one. So just hold, let me go on that code. So the root is what? Root is 5. So just write here 5. Okay. Now the prompt is coming like enter left of 5. So left of 5 is what? It's a 4. So just enter here 4. Why the prompt is coming like this? Because we have called the create function. So create function is available here. This one is create function. So after enter data, the prompt is coming enter left of that X. So if you require the code of this, you can just comment in the video. I will share that code also with you. Okay. So this is the left of 5. After that, what is the next prompt? It's coming like enter the left of 4. So left of 4 is what? That is 6. Okay. So this is the tree that we are talking about. First we have entered 5, then we have entered the left of 5, that is 4. Now the prompt is coming like here, enter here the left of that 4. So it's a 6 like this. So I will enter now. 6 we have entered, now 6 left. So 6 has not any left. So what I will enter? I will enter -1. -1 means what? -1 means return null. Means don't create any new node. Okay. Then it's asking enter right of 6. So right of 6 is again nothing. So again enter -1. Okay. Now the prompt is going up. The prompt is moving here. Okay, the control is going here only. Now we have entered, this is what? -1. This is also -1. -1 means it's a null. Now the prompt is moving here at the up. It's asking enter the right of 4. So right of 4 is what? That is 7. So you can just enter 7 here. 7. Now the next prompt is coming. Enter left of 7 and right of 7. So that is again -1 and -1. Okay, so -1 means you don't have any new child for the 7. So this is again -1. This is also -1. -1 means again remember this is null. We have defined. Okay. Apart from this, so what we have now, the prompt is coming for enter right of 5. So right of 5 is what? We have defined something as right of 5, that is 3. So just mention here 3. So 3 is left, it's asking. So it will be again -1 and 3 is right is again -1. So after that, what we are getting? We are getting here 64753. So this is what? This is the required pre-order traversal. At the bottom we are getting. So do check, are we required here 64753? So this is 64753. So this was required in order traversal. So here, this was your in order traversal into a non-recursive pattern. So this was our today's code. Hope you understood completely. If you are still having any doubt into your mind, so please post your queries into comment, or you can just post into chat box. Anywhere you can just connect. Okay, so thank you everyone. Thank you for watching.